I am Ashish De. I am taking one of a subject, that is Signal and System. Subject code is EC303. So you have to know first what is signal. Signal is anything that carries some information. The definition of signal: a signal is also defined as any physical quantity that varies with time, space, or any other independent variable. Okay, so example of signals, some signals. ECG signal is the full form of ECG is electrocardiogram. EEG signal, electroencephalogram. So that are basically biomedical signal. Apart from these, there are speech signal, electric signal, magnetic signal. So there are various kinds of signal are there. Okay. Now, classification of signals. Signal can be classified into two types. One is continuous time signal. So continuous time signal. Another one is discrete time signal. Now, what is continuous time signal? The signals that are defined for every instant of time are known as continuous time signal. Okay, continuous time signal is denoted by x of t. Suppose x of t is represented by a sine omega t, then the curve of this signal can be represented by a sine wave. Okay, and it looks like this way. So along x-axis there is time t, and along y-axis the signal, that is xt. Okay, so x is a function of t here. What is t? T is nothing but time. Okay, so how many time it takes to flow the signal, that is represented by t. Okay, here we can see that we are getting the value of xt at every instant of t. Okay, say for this time instant t0, the value of this signal xt is this. Again, at time t1, the value of the signal is this. Value means amplitude. Okay, so amplitude is this. Now in between t0 and t1, there have some values of xt. Okay, so we can get the value of xt at any point of time. Okay, that's why this is called continuous time signal. Signal is continuous during the time interval. Okay, that's why this is called continuous time signal. Now another signal is discrete time signal. If we represent this continuous time signal as discrete time domain, then it can be represented like this way. Okay, so these are the discrete amplitudes. Okay, here the time is indicated by small n. The name of n is discrete time index, and any discrete time signal can be represented by x of n, that is function of n. So here we can see that we are getting the value of this signal. Suppose this signal xt at a particular interval of time. Okay, so suppose this, and this is 0 1 2 3 4. like this way. Since n is an integer value, so it can have any value, uh, some negative values or 0 or some positive values. Okay, all integer values, on all possible integer values are there. Okay, so here the duration between two samples, time duration between two samples, say it is capital T. Okay, now this capital T is constant during the entire curve of this signal. Okay, so this is also capital T, this duration is also capital T. Okay, so time interval between two samples are constant. Okay, now this capital T is called sampling period. Sampling period. Now here we just convert a continuous time signal into a discrete time signal. The process of converting a continuous time signal into discrete time signal is called sampling. So this process is sampling. In the process of sampling, we are what we are doing, we are just taking some samples of the signal xt at a regular interval of time. Okay, so this interval is capital T, that is known as sampling period. One thing has to be remembered, that a signal has various components. Okay, any continuous time signal xt, so any continuous time signal xt can be represented by a sine omega t plus phi. Okay, so any electrical signal can be represented like this way. Okay, now here a is known as amplitude of the signal. Amplitude. Okay, what is omega? Omega is angular frequency. Okay, omega is equal to 2 pi f. The relationship between angular frequency and the normal frequency is omega equal to 2 pi into f. F is the frequency. What is the unit of f? That is hertz. The unit of f is hertz. So unit of omega is radian per second. Okay, now what is t? T is the time needed to flow the signal. Okay, now what is phi? Phi is called initial phase angle. So phi is initial phase angle. Now this total angle is called phase angle. This total angle is called phase angle. Okay, now why phi is called initial phase angle? Because at time t equal to 0 we are getting the phase angle that is equal to phi. Okay, so at initial time we are getting the phase angle as phi, that's why this is called initial phase angle. So just remember this thing, all the portion of a signal, okay, of a continuous time signal. This is also valid for discrete time signal. Okay, a discrete time signal is represented by xn equal to a sine omega n plus phi. Okay, here n is the discrete time index. Remember that n is an integer value. Okay, it may have negative integer or 0 or positive integer value, but here the continuous time t is integer, or maybe it may be a fraction value. Okay, so just remember this thing. Now mathematical expression for sampling is we have to convert just xt into xn. Now the process of converting xt into xn is xn is equal to xt at time t equal to nt. We are just putting t equal to n into capital T. What is capital T? That is sampling period. It is constant throughout the signal flow. So if we just put t equal to nt, then it will be x of nt, right? Now since t is a constant term, this x is a function of n only, so it can be represented by x of n, since capital T is a constant term. Okay, so we are just converting a continuous time signal into discrete time signal by adopting this process of sampling. So this is the process of sampling. Okay, another process that is called quantization. Quantization is the process of converting a discrete time signal into digital signal. Okay, so that is another thing. You will read that portion in your upcoming semester in digital signal processing. Okay, so just remember the process of sampling. There is a problem when we are doing the we are going through the process of sampling. The problem is known as aliasing. So the problem is known as aliasing. Aliasing is the interference between two successive samples. Okay, so if one sample overlap with the other samples, other identical samples, then we cannot identify the different type of samples. Okay, that is a problem when we recover the original signal from the discrete time signal. Okay, so that problem is known as aliasing. Okay, so aliasing will be described in your next chapter, in your last chapter thoroughly. Okay, so what we learn from this video, we learn the definition of signal. There are various examples of signals, classification of signals into two types: continuous time signal and discrete time signals. How to represent a continuous time signal, also a representation of discrete time signals, the process of sampling, and each component of a signal, identifying each component of a signal. They are amplitude, frequency and phase angle, right?